with the idea that those cells will create negative consequences. And Diana Bianchi, you told about her. So she's an American scientist, and she discovered in the 1990 cells coming from fetus inside the mother body can stay longer than 20 years, actually. Big wow, because at that time, we supposed that those cells were only there, during or just after the pregnancy. Those cells could not stay forever in the tissue. And she discovered that those cells can actually settle probably forever in our tissue. Those microchimeric cells are, what we understand now is that cells can go through the placenta. We first thought placenta was like a really frontier that nothing can go through. Of course, that's not true. We know, alcohol can go through, drugs can go through, bacteria can go through, and even human cells can go through. And human cells can go through in both directions. It means it can go through the fetus to the mother organism. It can go through from the mother organism to the fetus. Okay, that's a two-way direction. And also it's important to understand that it's not only a pas de deux between the mother and the fetus. Other individuals can be involved, because actually all the cells within the mother body can go through the placenta. So the mother, she carries her own cells, but she also carries her mother's cells. And the French team recently discovered that newborns can carry grandmother cells, and mothers can also carry cells from their fetus. That's what I told you, because it's directional. So by this mechanism, we can also acquire cells from our elders, because let's say my older sister, she sent cells to my mother, and then when I arrive in her womb, those cells can go back through the placenta, settle in my tissue. So in that way, you can carry both your mother, your grandmother, but all your elders. And when I'm saying elders, I'm not only talking about born child, because we know also that unborn child cells to the mother, so miscarriage or abortion. Those fetus, those embryo can send cells to the mother organism.
Welcome to your journey to find true tranquility on the Tranquility Magazine podcast. Please become a subscriber now to help us create more engaging and uplifting content for viewers and listeners like you. With your host, Jasmine Maya Royce. Today's episode featuring... For more information, visit our website at tranquilitymagazine.com.
Today, I am delighted to have Lise Barnéoud. She is a freelance science journalist who regularly contributes to Monde and Mediapart. She is the author of 2 books about vaccines, Immunisés and Vaccines. She won the 2008 Fondation Varenne Award for Science Journalists in the National Daily Newspaper and the Trophées Signatures Santé in 2016 Grand Prize. Currently, she is the author of The Hidden Guest, Migrating Cells and How New Science of Microchimeries is Redefining Human Identity. I am thrilled to have you and all your work combined in this book, but my first question is, what is your current mantra or state of mind?
Hi, yes, thank you very much for your invitation. Well, I'm not sure I really have a mantra. I think I'm trying to avoid this kind of photo loops. But if you ask me, then I will say that I'm a follower of the unexpected philosophy, which I would find as being always curious, open-minded, and ready to accept new ideas that go against your first foot or even your beliefs. And I think this is important both for daily life, but also for science and scientists.
Very much.
And I think this idea goes with another, maybe not a mantra, but something which is important for me, is to try to embrace all the nuances, avoid these black and white pictures that we see all everywhere, and to accept that reality is a lot more complex.
Yes, I think very true factors, especially for what you do, and understanding that science has sometimes a very clear direction and they don't like to, we would say, veer off, and open to changes, and the gray perspective is where the journalist finds the best stories, in my mind, in my experience. So what has led you down the journalistic path to science in your life?
Well, I was studying biology and sport biology specifically. And then I was ready to start a thesis. But finally, I changed my road, and I choose science journalism, because I thought I would have more opportunities to discover wider picture than, scientists are often very specialized. But I needed a wider picture, and being a science journalist allow you to speak with all the scientists without doing the lab work. So that's why I switched. So now, since 20 years, I'm a science journalist, working mostly on biology, medicine, and environment topics. And I work as a freelance since the beginning, because that's my choice. I choose to be a freelance because I really like the freedom it goes with, and the fact that you can, take a very long time on one topic. Sometimes when you work in the media, you cannot allow you to work for 1 year, like I did for Hidden Guest, on one topic only.
Yeah, I think I agree with one of the reasons that I found myself in journalism, that I like the broader sphere of different elements to focus on. In my youth, I didn't want to do one direction. I just saw the world as an expansive thing. And into science, as you said, you can see different fields and focus on something that is not your specialty or needs to
Exactly.
be. But
Yeah.
so in that, you can take your time as a freelancer. You can pitch an article or a piece like your books, and you have that breathing space to develop it, where it's not in the, we would say, hot seat, where you have to, crunch out anything for news today, tomorrow, fast.
True.
Yeah.
True. And you can make bridges between, different field. And sometimes scientists cannot see these bridges because they are so focused. And that's really interesting to be like one step behind.
Yes. And I love the fact that for most of your interviews or your key characters, that I would say characters lightly, actual humans doing the work, you have bridged the gap of a worldwide perspective, because people seem to be everywhere, that you have, delved into your book. So why did you find yourself specializing or creating the book, The Hidden Guests?
Well, I think it all started with my first book you spoke about, on vaccination and immunity. So it was in 2017, and I had one chapter on immunity and why we have a wrong vision of what is immunity. If you remember in your school back then, we usually learn that immunity is a kind of very intolerant system, like an army, which is around our body, controlling our frontier, and systematically casting out the non-self, the strangers. And I was writing an old chapter to say that this vision is not scientifically the right one. And I was reading science articles, and in those articles, they usually give three exceptions to that classical vision of immunity. So the first one is pregnancy, because of course we are allowing a semi-foreign body in our in our body during the pregnancy, semi-foreign because it's half you but half the father. But still, in the classical vision of immunity, you shouldn't accept this foreign body and you should reject it. And it does not happen most of the case. The second exception was microbiota. We are hosting billions of microbes inside us. And not only our immune system doesn't reject those microbes, but they are really useful for our health. Mm-hmm. So that was the second exception of this classical vision of immunity. And the third exception I discovered at that time was microchimerism. Mm-hmm. And I was really upset because it was already 20 years I was telling stories on our biology. And that was the first time I hear about this word, microchimerism. So I started to dig in this phenomenon, and I just realized that it concerned all of us, and nobody have ever heard about that phenomenon. Not only us lay people, but even scientists. Very few scientists knew about that, and I thought it's such a big discovery for me. It was like a wow, this exists for everyone, that I thought, okay, we really need to make a book on that topic.
Yeah, I think it's very true what you're saying about people in specific niches in science kind of getting focused, which you talk about, someone looking for something specific, you touch it on a way like the spotlight effect. It's one specific area that you're focused on, while all the other things kind of go in the back that you're not considering. And also, when your science develops rapidly in ways, but the acceptance of it for other scientists takes some time for validation. And you do speak on a specific person, Diana Banaucci. I may see her name wrong.
Diana Bianchi, yeah.
Bianchi. So her discoveries you talked about in the 90s and through on to be a very pinnacle aspect.
Yeah, but actually, the story is even longer, because the first one that has discovered the presence of chimeric cells in a body was a German pathologist in 1893. He discovered it was in women who died from eclampsia during their pregnancy. Eclampsia, it's a disease where you have this really huge seizures.
Yeah.
And sometimes you died. And
very common at that time, I would think.
He discovered in their lungs cells that were not cells from the mother. And finally, he discovered those cells were coming from their fetus. And at that time already, he said, wow, maybe fetal cells can go through the placenta and enter in the mother body. But then at that time, we thought, okay, maybe it's what caused the disease. Maybe it is what caused the death of the mothers. Also because after that, we still discovered cells from other individuals in the mother body, but we always thought it could be a problem, because we thought, okay, if different kind of cells settle in our body, then the immune system should attack it. So yeah. Either the immune system doesn't attack it because we are too weak, that's why we have disease, or maybe it's because we have because it creates some chronic inflammation. Mm-hmm. So that's what you said just before. During a century, we had a spotlight with the idea that those cells will create negative consequences. And Diana Bianchi, you told about her. So she's an American scientist, and she discovered in the 1990 that cells coming from fetus inside the mother body can stay longer than 20 years. Actually, I think her study, a big study, was 24 years, and it was a big wow, because at that time we supposed that those cells were only there, during or just after the pregnancy. Yeah. But that those cells could not stay forever in the tissue, and she discovered that those cells can actually settle probably forever in our tissue. But maybe I should explain now a bit more what those microchimeric cells are, because I'm supposing everyone know, but I know that's not the case.
True.
So actually, what we understand now is that cells can go through the placenta. We first thought placenta was like a really a frontier that nothing can go through.
True.
But of course, that's not true. We know, alcohol can go through, drugs can go through, bacteria can go through, and even human cells can go through. And human cells can go through in both directions. It means it can go through the fetus to the mother organism, and it can go through from the mother organism to the fetus. Okay, that's a two-way direction.
Yes.
And also it's important to understand that it's not only a pas de deux between the mother and the fetus. Other individuals can be involved, because actually all the cells within the mother body can go through the placenta. So the mother, she carry her cells, but she also carry a mother cells. The French team recently discovered that in that newborns can carry grandmother cells. And mothers can also carry cells from their fetus. That's what I told you, because it's directional. So by this mechanism, we can also acquire cells from our elders, because let's say my older sister, she sent cells to my mother, and then when I arrived in her womb, those cells can go back through the placenta and settle in my tissue. So in that way, you can carry both your mother, your grandmother, but all your elders. And when I'm saying elders, I'm not only talking about born child, because we know also that unborn child can send their cells to the mother. So miscarriage or abortion, those fetus, those embryo can send cells to the mother organism. And last one, it's also from our twin, but not only the born twin, which is really few of us have twins, but also what we call the vanished twin.
Okay.
Which means the first days, weeks of after fecundation, sometimes two or more embryo formed, but some will disappear and only one will survive.
Yes.
But the one which will survive will acquire cells from the other embryo.
Yeah.
And those situations often create a lot more cells, and that's not microchimerism, but macro, like many cells coming at the beginning of our development. So it could constitute an old tissue, for instance.
So, I mean, you go into a lot of expansive ideas in this regard on how our bodies develop over time with added cells or growth, or the term you want to see is as a part of you now. Like you're dealing from the past and the future of the birth, and then you're assimilating them into your system as part of you, which I find awing, to say the least, in so many ways, that even you spoke about the concept of a miscarriage or an abortion, the still cells live in your body, and then your sister or your brother that came before, those cells become a part of you in the mother of the birthing element. And then as you proceed through the birth canal, all those elements kind of align to become what you are going to become. But also the idea of the placenta, going back, that it is not a caged force that can't be penetrated. It's, extracting and creating things to come in and out while the birthing factor is happening. So you touch on some past ideas in the 1800s and such that we thought the placenta is a very strong substance that you cannot get into, where there was a lot of studies that you approached where it resonated with me because you were talking about the fact that they were trying to heal nausea from women having for the birthing factor, and it was creating some special needs children or things with difficulties because they thought at that time that placenta wasn't penetrable, which you did a research on that regard when they were studying an extraction before birth and then into the womb by a scientist that was using, I believe, ultraviolet or not the right.
But to the fluorescent, they were using like fluorescent molecule to tag the cells, was it?
Yes.
Yeah, and then that's really helpful because you can really visualize how those cells are going out from the placenta and where they're going inside the mother body.
Yes. So they were extracting from the umbilical cord these cells that they found when they put them back in the mother, that they were determining that these cells can go through all the placenta and into the birthing channel and for, the baby, so to speak, as part of it after they thought it wasn't an impenetrable force. But speaking on that, you're talking about the Y and C chromosomes to be found in both parties and how that was very unusual. And I think that's part of the microchimerism. I'm not going to say it right.
Chimerism.
Thank you. Chimerism. I'm still going to say it wrong. But in that, like, you were talking about finding a lot of Y genes in a female where it wouldn't be expected in this conversation we're having right now.
No. Well, it was a trick from the scientists to distinguish cells. Let's say you are a mother of a boy. So boy have Y and X chromosomes, sexual chromosomes, and we have XX sexual chromosomes. So at that time, because we hadn't more tools, we were looking for the Y chromosome in a human body to look for cells that were coming from a boy. So supposedly from a fetus, a male fetus. And it could be the opposite, looking for XX cells in a boy. And then those cells could come from the mother, for instance. So it was more a trick from the scientists to distinguish these cells. And now we are using a lot more specific tools that could, for instance, if I know the specific characteristic of my grandma's cells, I could try to have a look whether I carry her cells in my blood, for instance, or in my tissue, which is quite difficult because then you need to look inside the tissue. But that's some techniques from the scientists to pick these different cells, these different genetic cells.
Because you were expanding about that, lineage of past dated and current concepts being embedded in organs, especially the liver, where some difficulties were happening. In some deep collaborations going into your chapters and from Diane's work and into this Dr. Nielsen and her development on autoimmune system, what were some of the findings that you came across that you think are important to share?
Yeah, it was funny that in the same time, there was 1990, two women, one on the east coast of the US and one on the west coast, so Diana Bianchi and Lee Nelson. Well, actually, they discovered the same thing, the fact that fetal cells can stay longer in the mother body. But Lee Nelson was a doctor, and she was studying autoimmune disease. And her idea was that maybe those cells that are still different from our cells could explain some autoimmunity disease. This disease and your own immune system are attacking your own cells, but maybe your immune system could attack those chimeric cells because they recognize for a reason or another that they are not the same cell that your own cells.
Yes.
Or maybe these chimeric cells could also attack your organs because some of those cells are immune cells. So she had this hypothesis at that time, and I have to say that right now we don't have a solid answer, but it might explain some case of autoimmune disease. We have now new studies, and it depends on many things. It depends also on the characteristic of the cells you acquire and the events you have in your life.
Yeah.
But maybe if we because I don't want to let the people think that those cells might only hurt them.
Yes,
Because
that's right.
actually what I discovered is that it was the first idea. Those cells might make some troubles. But finally, we discovered that those cells can also be very helpful, especially fetal cells that settle in the mother body, because we understand now that those cells are not traveling randomly in our body following our fluids, but they might be attracted by some molecules, which are called chemokine. And those molecules are emitted by cells that are injured. For instance, if I cut my hand, then those cells on my skin will produce chemokine, and that's a molecule that our immune cells are able to sense thanks to receptors in the membrane.
Yeah.
But we discover that fetal chimeric cells, they have 100 more receptors for chemokine than our adult cells. So they can hear this signal from far away, even if the signal is weak.
Yeah.
And they will follow, the kind of a gradient concentration of these molecules until they will reach the cells that are producing these molecules. Let's say that's my skin because I cut in my hand. Then when they will arrive here in my wound, they will produce blood vessels, they will produce collagen, they will produce skin cells, and actually they will help to repair the injury. And that's the beauty of these cells, is that when they settle in an organ, they can adopt the specifications of the organ. So if they settle in my heart, they will specialize in cardiomyocyte, and they will beat around the other cells. So you might have cells from the embryo you carried in your life inside your heart beating among the other cells.
Yeah. So assimilation, making two things kind of part of a whole now and being collaborators in that to wander off. I would give an analogy to what you were talking about before. We have the paramedics arriving onto the scene of the accident, and then they go to a hospital for your chimere, being the paramedics, and then these other microcosmeres being the hospital that has more infrastructure to kind of heal the wounds and make it heal maybe faster, because they may have more medication, more people on hand, and all those things that they provide a better infrastructure to heal faster when, the chimera alone can do some work, but they can have an extra hand to help out and, heal faster, which is a very important idea to kind of break through our new science and new renovations, or that's kind of a mixed word in a way, new theories that are coming to the forefront that are about how our bodies are not always fully our own.
Our bodies display a boundless hospitality, and the body made right since the beginning from the others, and that's what defines us, made from the others, and those others really help us to teach, for instance, our immune system. Those we have shown some research in Germany especially show that cells from the mothers who settle in the fetus are really essential to teach the immune system of the fetus. Same for the neural development. So right since the beginning, we really need the others to be ourselves. And actually, we couldn't even talk anymore about ourselves and non-selves because we are a collective of cells, human cells, non-human cells. And within the human cells, we are still a collective of cells because they are our own cells, the one who come from our very first egg, and which divided in 100 million cells. So that's most of our cells are coming from this first cell.
Yeah.
But among these cells, we have other cells coming from other individuals, and they look like really important for biology. So yes, we should see ourselves like a collective of cells.
Yeah, I think it's important for me. I will go a little abstract on that because you made a great example. Two scientists at the same time discovering the same kind of theory at different places. And it goes back to the idea of paper. And paper was crafted at a certain time from two different cultures in opposite sides of the world. And Egypt and China, that they had no collaboration, but they created paper around the same time. Sometimes it becomes common conscious, and we're all a part of each other in a way. But I will give another example that the first time I saw my niece, we hadn't met before, and she was already 2, and she didn't really like people that much, but she clinged on to me and everyone in our family that she's met beyond that moment, because for some reason, genetically or inherited, she felt safe and familiar. And that's part of, the community of family and the same genetics that we kind of resonate to each other.
Yeah, sure. But not only we share genes, that was known for a long time, but we also share cells, and cells are like little block of matter, right? So it's kind of different there. That's even more wow. That's not only genes, that even some block of matter. There is one research that was really I was impressed by. It was on mice, and it tried to see how long could these microchimeric cells survive. So I told you, the mother and her cells to the fetus, and then the fetus become a mother, and she can send the grandmother cells to the fetus. So that go always and always from generation and generation. We didn't know that. So they tested on mice, and they discover that the same cell lines. It's important to understand that it's not the same cells, but the same cell line, because a cell doesn't survive that much, but those cells can renew. Depends which kind of cells. Neuron can be several years, but some immune cells can be only several hours.
Okay.
But microchimeric cells, like some other cells which named stem cells, they can renew themselves. They can divide into daughter cells, and that's how a cell line can survive. It's not the same cell. I mean, the cell from my mother I carry now are not the cell that have lived in my mother body, but that cells that are daughters from the cell that lived in my mother body.
Yeah.
So in that experiment within mice, they discovered that those cell lines can survive 51 generations. Wow. 51 generations in human is like 1,000 years. So it means if by chance a cell could have survived, coming from mother to her fetus to the fetus of this mother, it's like going really far away.
Yeah.
And also it means that our death doesn't mean that our cells will disappear. And that's also philosophically something I thought really strong. I never thought about that before.
Yeah, I mean, that's a huge amount of ancestral right there with living and breathing. If I get into like physics in a way that nothing ever dies, it just dissipates. It has recreation, then it goes to some different direction in its own regard, but it's still alive and living, just takes a different form. And now we have your perspective that it's about your grandmother's grandmother's great grandmother on through the lineage is still existing as you as the element of life right now. And then if you have children, that ancestral still continues on and lives in your body as part of who you are in certain aspects. But it's just profoundly enlightening in so many spheres about who we are becoming. And I think you touch on personalities too, with, how they develop over time into your body and become what your present form is in that concept. But yeah.
Yeah. So some researchers even think about ourselves more as an ecosystem, having different spaces.
Yes.
Then it will mean different cells, like different microbe cells, different human cells, and that we need this diversity to have a healthy ecosystem. And actually, that could be the same for our inner ecosystem. We need that diversity to be healthy.
I think, understanding a lot of the conquering of our health and what we already have in our body is part of us, and how to identify that to help us with certain things. It may be a help or it may be a hindrance, depending on what we have now imparted is part of us. And so it is important to keep that as top of mind in how science has navigated forward for a different perspective on our inner working of our inner cells and our little invaders that are taking over in benefit or detriment. So I always have two questions at the end. My first is, what is the best advice you've ever received?
To have a link with our topic, I realized, thanks to some researcher, and especially one Canadian woman named is Erin Martin, I realized that the language we used could have an impact on the way we are looking to ourselves. I mean, in that chimeric story, but also in the immune system articles I can read, we often see very martial language. Do you say martial language?
Not really.
No, okay. We encounter a lot of metaphor linked with war, the war.
Yeah, the war.
Now, there is the army of ourselves, killing the invaders, and those language, those words finally make us vision we have of ourselves, and we little by little we see ourselves like a pure self that to defend against the others.
Yeah.
And we see ourselves against the others. And I think if we were more aware about the impact of the language on the vision we have of ourselves, then we should use some other words to define our biology, because we are not as an army. We are more very open, very body with boundless hospitality, and we need the others. And I think it could change maybe the way we are also in the world. And that's one of the advice I understood during my investigation.
I think it's so important I say this often, words have power and they also have meaning. And sometimes the same word can mean something very different to someone else with different backgrounds and different cultural understandings, and how these words impact the phrasing that we give something. And you speak about it often throughout your book about, and you were talking about it right now about we're at war with other things. And then kind of taking that for an analogy that I'm familiar with, it takes a tribe to build a family or to take care of a youth. You need the tribe. You need all of the things that are imparting to be you that are impacting the situation, that you need to be more, as you say, hospitality and welcoming to your hotel of self, that you are inviting these guests, as you say in your title, the guests that are here to arrive, because it's so important to have them. And they make you, I would say, more expansive as a person, more broad as a concept, more worldwide perspectives as part of you and who you are now, as all these little additions of creation, these inspirations for wherever you found them in your journey of who you are now. The heart.
And that's George Orwell say that. He say that the language can corrupt the food. The food can corrupt the language, but the language can corrupt the food, and that's really important to have that in mind. I think even when we are writing out scientific article, more and more when we are writing journalistic text.
Because you're a very beautiful writer in your creative formatting, because you want to make it immersive for someone that's not in the specific field, that doesn't understand the cadence or the abbreviations, which I have a hard time with. What is that? And define it for me.
Yeah.
And you do a lot of, we would say, flowery description in a nicest way of, leading us on this path to kind of discover about something, that you need a lot of these analogies or common wording to help people understand something. But in that, it's still a detriment where the words need to evolve and change over time. Yeah. And sometimes people have a harder time with that changing of a common phrase that they've been using for decades. And you're now, what is that? Like,
of course, I know.
Yeah, I'm sure you're very familiar. So my last question is always, what is the biggest takeaway from the hardest lesson in your life, and what have you gathered by it?
Well, you just talk about trying to phrase difficult discovery, difficult idea to be understood by everyone. So maybe I could say that, for instance, I did make my book read in advance by my father, who is really not in biology, and he was first really understand little in biology, and that was really hard for me to be sure. I wanted to be sure he could understand what I was writing, so everyone could understand what microchimerism is. But it's the same for every article actually I write, and that's a tough work to be sure everyone can understand you, and as you say, with metaphor, but metaphor that won't corrupt our thought. So I don't know what my best takeaway, but maybe just when you want to be understandable by everyone, just talk to people around you and make sure people understand what you want to say, and there is no misunderstanding at this first step, and then you can allow yourself to speak to other people.
I love it as the ending note on collaboration, because what you're saying right now is also go throwback to what we've been discussing the whole time about collaboration in our bodies, that we need that's conversations to make sure that we are having the same dialogue always, that like, are you good? I'm good. How could you help me? I need help on this. Maybe you could help me. And so these are the cells in the form that you have spent so much time researching, that you're now an actual person doing it in the world to ask these questions from, your father, so to speak. It's part of your genetic understanding. So it's a perfect example of exactly what I was talking about on understanding how these little elements can impart their truth. So thank you so much for your time. I'm so excited for everyone to pick up The Hidden Guests. It is a great exploration on new science and figuring out about the microcosmere and the redefining of human identity. Please check out all the notes before and check out her new books. And if she has anything from Le Mode she wants to share with us, we are always open to giving that to our listeners. Thank you very much for your time.
Thank you. Thank you, Yasmin.
Thank you for tuning in to the Tranquility Magazine podcast. Please take a moment to become a subscriber. We are here to help you with your body, mind, and spirit. We want to thank our team for helping create every episode and content at tranquilitymagazine.com. Find us on our social media to stay up to date and informed. We always appreciate your engagement and feedback.